Hello everyone, welcome back to the channel. Today we are going to dive with the topic, the next part of your data analysis. This is the model implementation. How to transform the data and build the model. In yesterday video, I have explained about the step-by-step data analysis. When you have the real-time data set in your hand and you are thinking from where I should start, right? So that is the best video for you. In my previous video, I have explained about the what points you should keep in your mind when you are doing the analysis. I have also explained about the feature importance, so you can draw the graph according to the feature importance. If you have a 20 or 50 features in your data set, it doesn't mean you are going to draw all graphs for all features. Okay, you have to do a lot of brainstorming. Third, I have also mentioned why you need to make a copy of your original data set, which is the most important part. Okay. And then I have told you how to check missing value, duplicates, outliers. Okay. So today I am going to continue using the same data set in part 2, in which you will learn many things. Number one, how to again we will check the missing and duplicates. If you are going to use a separate file, I am going to use the same notebook. And then number two, how to handle the outliers. Number three, how to handle the missing value and transform the data. Number four, you are also going to learn the most important part, that is use of pipelines and column transformers during the machine learning, which is the fastest, clean code to build your model. Okay, so if you don't know anything about the pipeline and column transformers, formers, so I will explain it in detail today. So you will understand. Okay, and the next we will apply one model, implement, and then I will show you the accuracy metric too, confusion matrix, precision, recall in detail. I will also make tomorrow the third part of this same use case, in which I will tell you the comparison of two different models and their evaluation metric. Number four, how you can hypertune your models using the next algorithm. So if you are going to watch all these three videos, you will be very strong in classification. Rest, some problems come up with the different kind of the data sets. We are using here churn data set. So we are also discussing the problems you might face during the churn data set. Okay. So you are going to learn very interesting thing today about the your missing value actually. Okay. So let's start without any delay. Let me share my notebook. Here we go. Okay. Okay. So now this is the part 2. I'm using the same notebook. So that's why I'm not loading the data today. It is already loaded. Okay. So here, these are the steps you are going to cover up. You can make a copy of the original data set again if you want to use a separate notebook for model building. Okay. Choice is your, no problem at all. So here we are looking at the data set. Let's just explore it again, right? Because we want to build it. Now, this is your target variable. Your goal for this project is to predict whether the customer will churn or not. Okay. So this is the total charges based on these given feature, right? Total charges, monthly charges, payment method, paper billing, senior citizen, partner, dependents, so many things, tenure. This is one of the most important feature, right? And then here we are just checking the using the info method. Now look at this. Did you notice yesterday we also checked the missing value, but it was showing zero missing value. Look at this, no missing value. When I am checking this is null method, it is also no missing value. But look, did you notice here? This is the total charges and it is coming object type. It is integer, right? So total charges means nothing like the your this one like the categorical. You can look at this total charges. It is numeric or float, right? So this means we need to look at it carefully. Okay. Now you will understood the importance of info actually. So you have explored see the importance of head to. You see the value, this is coming all in the floats, and here you are looking at using the info method. It is showing the object data type. So this means you need to handle it. Okay. There might be some missing value which we are not able to see right now because my is null method is not able to detect it. Okay. It happens sometime. This problem is in this data set, but it might be happening with your any other data set too. So my goal is to why I'm highlighting this point, because I want to like make build you expert and the strong foundation in machine learning, because these are the small points you should keep in your mind. Because when we use the info method, we are very happy, oh, there is a no missing value, and we are not focusing actually on the data type here. Okay, which is also the most important part. I have mentioned it yesterday as well. Okay, but it was not important at that time there, because we were not going to handle the missing value during the analysis. It is only exploration about. Today I need to focus on this because I want to build the model. Okay, so now look at this total charges, no missing value. Okay, so now I will like try to check the missing value using this one. Okay, so look at this 11 missing value. Okay, so there are 11 missing value exist in your total charges. Here it is showing 0. Why? Because it's a data types is object, and when I am applying to check the missing value using isNull method, it is not checking for the empty actually. It consider the empty as something, right? And it is saying you no missing value because it doesn't work with the this one. Because isNull only work with the missing value if it is either filled by NaN. Only this is the way. Okay. So here you can do one thing. You can replace your space with the np.nan. Maybe you are thinking, how would I come to know if it even it is object type, there is a no missing value or there is a missing value. So like the first thing here you can notice, we have look at the head data, right? We have look at the head data and we are looking at it. It's a float, right? This is the first sign. Okay, second sign, if you have a doubt, you have a many columns and you are in a doubt, it should be float or integer, but it is coming up with the object, then you can convert them into numeric. Okay, using this one pd dot to numeric edf total charges. Don't try to convert whole data into data type integer. Just choose carefully which column you want to convert into numeric from object to numeric. Error is equals to chorus. It will avoid to like to show or raising error during the when it is converting your data into integer. It will help you at that time, okay, at a runtime. So it will not stop your execution. It will convert your whole data into numeric data type. So you should use this parameter. This is very important. Okay. And then here I have replaced NP and this one as well. And then I am converting the total charge to numeric. Okay. So if there is any non-numeric value, it is also going to be help, as I told you, right? So there is a non-numeric value is NaN because we have replaced it with the NaN, right? So that's why it is there. As I told you, otherwise it will throw the error. Okay. Now look at this. We are checking is null.sum. Now it is showing you 11. Here, you have learned one very important thing. If you know the data type is in integer or float, it should be, you are sure, you have talked to the stakeholder, you have talked to the domain expertise, they are telling you your total charges are either integer or float, but the data they have provided you, it is not coming up with that data type. So it is your duty as a data analyst or data scientist to convert it and check then missing value. That's why now you may understood the importance of talking or communication with the stakeholder and domain expertise. Why we focus on this? Why I was pushing you just talk to the domain expertise, understand about the data dictionary in detail. Okay, this is the reason. Okay, now we will check the duplicates. Okay, so we will check the duplicate. There is a 0 duplicate. So don't worry, if there is a duplicate, delete it without any second thought. It is not going to like affect any your performance of your model. Okay, no use. Yesterday I have mentioned, now we have checked the basic steps, which was important because the analysis I have done yesterday. Today my goal is to prepare the data for the model actually. So that's why I'm not doing any other steps here. Okay. So now here we are going to do what? Here we have seen from sklearn model selection, train, test, split, sklearn preprocessing, robust, scalar. This is we are going to handle the outliers actually. Okay. So now using the for the train and test, if you want to split the data, first you need to declare separate the x and y. What is x? X is your independent feature, right? Using which feature you are going to predict your whether the customer will churn or not, right? Like total billing, total charges, monthly charges, paper billing, senior citizen, tenure, your partner, right? Many things are there, right? And then X is equals to EDA underscore DF. I'm just deleting the customer ID and churn both from independent feature. This is our goal, right? When we separate the data, we separate the independent and dependent feature. My dependent feature is churn because I want to predict it. So we will delete it from the X feature. Maybe you are thinking why I'm deleting the customer ID, because customer ID is something not going to contribute in your model performance or learning. Okay. Even if you find the customer ID or any ID column in your data set, you can delete it without any second thought. It is not going to make any contribution in your model building. Okay. So I'm deleting it. Now we will use the train and test split method. We will pass the X and Y. I am keeping the test size 20%. Random state is equals to 42. Some students ask about it, why it is always 42 actually. If you want to take, there is a no rule, you need to keep it 42 actually. There is a rule behind the random state only parameter, because when you will see the output, you are rerunning the same cell again and again, right, for the prediction. So it should always show you the same value which you are looking from the start. It should not pick up the random value. That's why you use the random state actually. And whenever you are splitting the data, random state is equals to 42 means it is going to pick up your values, some sample during the training. And if you want to take a detailed look about this one, you can go with the Hitchker library. Okay, Hitchker guides. So you can read that article, why they are using the 42 only. Even you use 100 or any other number, it is going to work in the same way. Okay. And then we have split it into X train, X test, Y train, Y test. Test is your data which we are going to hide from the model. Okay. Now this is we have converted, and this is your the all values. We are looking at it. Okay. You have checked about, you have a 11 missing value. Okay. Sometimes students think it is a very less amount of the values, so I will drop those records, right? So you may try to delete the rows. If you are a beginner, I'm telling you, when we are talking about the deletion of the missing data, we are not talking about the column deletion. We are talking about the deletion of the rows actually. Okay. So keep in your mind. So here, deletion from my side is the last option. I never ever opt deletion method until if I found only one missing value or two. Okay, this is my goal. I always try to handle the missing value. Okay, but there are many different scenarios as well. I will try to make a video on those one as well, which is a really complex problems. But today we will continue with this one. So now we are not going to use the deletion method. This is for sure. Second thing, when you found the missing value in your data set, your second job is now to check if your missing data lie under what category. Does it lie under MCAR, MAR, or MNAR? If you don't know what is this, then you can check my playlist where I'm explaining it in the detail. Okay, this is called missing completely at random. This is called missing at random. This is missing not at random. Missing completely at random is you miss one question from the survey. They are asking your age, right? Let's say they are asking your income, but intentionally you don't want to share your income. Okay, so you are skipping that question. So this is called missing completely at random. But your salary, your income should not be directly connected with your target. It's a deep topic, but I'm just telling you in a brief. Okay. The MAR means missing at random. Okay. So it is like missing at random is if we are doing the medical survey, there is a age and blood pressure column. You are missing the age actually. We are predicting the blood pressure based on the age. So this means missing at random. You are intentionally, it is directly converted with your observed value. MNA are missing not at random, not completely at random. So in this, if you are a young, again, you are hiding the income and we want to know, decide your, let's say, position based on your package, something like that. Okay. If you want to learn about it in detail, you can. But this is your second job. You need to understand under what category your missing data lie, because many students does this, but at a beginner level, students usually don't do this. Okay. The reason, no boot camp, no one is going to teach you this thing actually. They will directly teach you just apply the mean, mode, median method, apply the regression method, apply the KNN method to handle the missing value, something like that. And when you see the numerical value, you will directly apply the mean method. And when you see the liars sometime and skewness, you use the median. And then for categorical, you apply mode. You don't even think one time like, is it really matter if I'm going to apply handle the missing value with the mean strategy instead of median? Is it worth for my model? Nobody think about it actually, because they are not here. You will not find this much detail actually anywhere. Okay, so now let's start. So this is very important actually. If you come to know under what category your data missing data lie, then you can apply the strategy according to it. Okay, I will tell you in the upcoming cells. So here this is, you can import the package missing number import matrix, matrix x underscore train plot dot show. Okay, here you can see if we just look at this, it is showing the small one. Okay, so here is the monthly charges. Okay, sorry, total charges. So total charges, here you can see the white line. So this means data is missing here. But you can see in other columns, all other columns, even like here in the contract, tenure, partner, and this, there is a no missing value, right? So this means this is not related to the other data. Okay, if I will show you the here one more example, this is, I'm just showing you the only about the X train, but I will show you with the your target too. So this is your EDA, this one. Okay, so we will plot for this one too. Look at this. So this is churn and this is your total charges missing, right? You can see here it is missing at some places, but did you notice it is not affecting the churn actually, right? It is not directly, we will say, like if this is the missing, then other values are also missing. There is no missing data. Okay, so this is the first point you can observe. So in this, how would you come to know it lie under this one or not? I will tell you. So this is like MAR, MCAR, you are missing completely at random. MAR missing at random, MNAR missing not at random. MCAR means missing completely at random. Like right now, it seems to be your MCAR. Okay, but we need to confirm this. Okay, so we will do it for the other way to check it. Okay, to confirm it. Here, this is another way to check under what category your data lie. Okay, if you want to look the detail for MCR or MAR, then you can watch my videos. Okay, I have made the very small shorts on this, so you can look at it. Okay, here. So first you need to create the here actually indicator. Okay, so indicator is nothing. We will create a one dummy like the new column missing total charges, X train total charges is now as dot type int. Okay. So we are creating this too as an integer variable where I am setting if value is missing, it indicates 1. It's an indicator column. It's not a missing value column. Missing value column is this one. We are just saying, I will make you understand here. Let me open my annotate. Look at this. So we will do this. So this is your total charges. Okay. And this is going to be your missing total charges. Okay. So now here, if you have the one, let's say 1.25, okay. So I will write the dummy number and this is the missing. Okay. So here is a NaN. Okay. And here again 3, 4 and so on. So missing indicator, what it does? If a value is not missing, it will indicate 0. Okay. But if the value is missing here, it will indicate 1. So it's a just indicator. I need it to confirm if my data set is lie under MCAR, MAR or MNAR. Okay. Missing at random. So here I will clean this. I hope it make sense to you. Now we are creating this one and then we will check the correlation between missing value and other features. Okay, because we want to know if your this feature is highly correlated with the other numerical feature or not, because this is the most important part. Okay, now we will pick up the your number data type. We will use the same method correlation which I have used yesterday too. Okay, and then we are just sorting the value. Now look at this. So your here this one total charges, it is 100%, it is connected with itself, right? But your total charges with the gender is not connected too much, right? It's a 0.00. So this means if the gender either male or female, it doesn't matter, it is not increasing or decreasing your total charges. Okay, this means that. And then senior citizen, it is 0.09. It is also connected with your total charges, very minimal, only like you can say 9%, right? So it means if you are either you are a senior citizen or not, it is not going to affect your total charges. Okay. And then we will look at the monthly charges. It is a 65% connected with your total charges actually. Highly correlated. This means if your monthly charges is going to increase, your total charges are also going to increase in the same direction. They are highly correlated. And then it is also correlated with tenure too. Okay. This means if your tenure, we can go back and look at the values of tenure here. Here we go. This one. Right? If it is increasing and decreasing, it is also affecting your total charges too. Okay. So that's why we are checking. It is very, very helpful to know whether your missing data is connected with the other or not. Okay. Now this is your just NaN because it is not any value. This is just the indicator. Same you need to check with the test data too, because we have already splitted the data. Okay. We are not going to do any fitting onto the model, but I will tell you what we are going to do with the test. Okay. So here you can see in the test. So it is showing the same result. Now, and now this is the definition. Look at this. If all correlation values are near 0, missingness is like MCAR. As I told you, right? This your total charges is like not connected with all features, right? It is individual. It is connected with some values, but not all. So we can write it is like if all correlations value are near 0, missingness is likely MCAR, right? So this means this is not the case of MCAR. Okay. By looking at the picture, That's why I told you you should use one or two methods to confirm whether your missing data lie under MCAR or MNAR or MAR. So here MCAR, it is not connected because all correlation values are near zero. It is not the case. It is related with tenure. It is related with monthly charges, right? And then if missingness correlates with the tenure or monthly charges, it is likely MAR because it is connected with the two of your features, right? If they are increasing, your total charges are also increasing. Okay. And then if missingness is self-dependent on the total charge itself, it is called MAR. This means if your observed category if your observed category has the missing value, when the missing value in the total charges, they are strongly with each other connected, then your missing data will lie under the category MNAR. So this case is cross, this case is cross. Your missing data lie under this category. Okay, this one. Because this is related to this one or your other features, right? So this means when you are doing the survey of this one, banking one, intentionally people or customers are like missing these values. Okay. Now I understood my data lie under MAR. Now I can think which like your strategy will work in a very good way, than the other one. If your data lie under this category, that's why you need to check it. Okay. If you want, right? My recommendation is just make your habit from the start of these kind of the things. Don't try to think like I will put it on the next case, because if you do these things with the simple cases, then it will be very good for you. It will start making your foundation. Actually, it will start fitting in your mind here. Okay. So here I am just drawing this graph. I have drawn the yesterday as well. This is, we are just looking at this graph. The red line is showing total charges missing. This is the indicator. This means between the range 20 to 80 monthly charges, this much missing like your value exists, right? Above we were not able to see during which range the missing value exists, right? You have the range minimum starting from 20 and it is going up to 120, your monthly charges, so it is missing here. Okay. Now, so here the missing value mostly occur at a monthly charges between the low range, right? And this suggests total charges value are not at random. That's why it's a MAR. Okay. So now this is, I have just written the dependency formulas for your knowledge. If you want, you can read it. Okay. I will share the notebook too with all of you. So it will give you the good, like the foundation. You can use the same notebook, make a copy, and then you can edit it. Okay. Now we will decide, we understood now my missing data lie under the MAR, missing at random, because it is correlated with the other independent features too, not with the observed one, churn one. Okay. And here you can apply these three methods actually. This is the biggest advantage. If you don't you don't understand under what category, right? It was the categorical data, right? And you think this is a sorry, not category, it is a numerical data. You think it's a numerical data, I will apply the mean method to handle the missing value. This was like a first thought come in every student's mind. Okay. As I told you, like in many boot camps or in like whatever you are doing these certifications, they don't teach you at deeper this level. I'm not saying anything against them, just I'm saying you because they want to teach you the basics, right? I'm teaching you the basics at a deeper level. Okay. So this is just for your knowledge so you can have the strong foundation. So here you have a three methods. This is your choice. Whatever method you want to apply, you can. Okay. But look at this. I am going to use this method. Okay. So here, this is a simpler approach useful when the dependency is categorical. Okay. And here we can like decide on the, but whenever you are applying the mean median methodology to, okay, so you should need to take care of this thing too. Okay, I will tell you the difference. Okay, now here best method is this. I'm not going to apply it. It will be the too much big notebook. So if you want, you can try the regression imputation and two, but I am going to apply this one. But if you want, you can try this one and then check the difference between the accuracy of the model. Okay, you can take it as a homework. Okay, now I will tell you. You might think if I am not going to check the category of the missing data, then I can directly apply the mean method. It is also showing. But this is the first scenario. If you go with the other use cases, there will be the different scenario. Okay. And it will guide you what methods you should use, mean, mode, median. Okay. Now, first of all, we will now separate your numerical data from your fact string. Okay, so we can handle the missing value now. Till so far you have learned the under what category your missing value lie. Now you have decided I am going to apply the conditional mean median method. Maybe you are thinking what is the conditional meaning? I will tell you now. Okay, so here I have importing the libraries which is important. This is standard scalar one hot encoder. This is this is the accuracy one. This is I have write because I don't want to show any extra warning in my output cell. Okay. And then I am going to use the function transformer here. I will tell you why. Okay. So now xtrain info. Here we are detecting the outliers. This is I have mentioned yesterday too. Okay. So this is the same code. We have a Q1, Q3, your quartile range. And then we are finding the IQ3. I'm not going to explain it in detail today. You can watch my previous video. And it is showing you the outliers here. Okay. So it is first we will check the outliers and handle them. Okay. So it is showing the outliers in senior citizen, this one. And there is a outlier found in missing total charges too. So this means which is the here it is saying you missing total charges outlier found because we have added the NaN value, right? So it is coming up within that, but don't worry about it. Okay, it will be handled. Now this is we are just plotting the graph. Look at this. There is a missing value. There is a missing value. Okay. So now, sorry, not missing value. This is the outlier. Okay. This is the box plot. Okay. So the data distribution is too close to each other. This means your all numbers range is very close to each other. So that's why we are not able to see the whisker plot box. Okay. Like this one. But it is showing this round circle is known as outliers. Okay. And then how we will handle the outliers? We will just use the cap method. So handling the outlier, you need to set the boundaries. Upper boundary, low boundary. We call it capping system too. There are other ways too, but I am using the cap method, okay, to handle the outliers. Some student thought, how would I handle it? If there are two or one outliers, I'm going to delete it. Okay, but sometime outlier, if you are thinking to delete the outliers, right? So maybe you are losing the data. Okay, and your model will not get the enough data because if we look at this in our case, we have a lot of outliers, right? I can't think to delete it and avoid it. Okay, so my goal is to just set up the upper bound, lower bound. This is I have mentioned yesterday too, how you can calculate it. So here I am just applying it onto the X train, X test both. Okay, so we are applying, handling the outlier in both. We are not fitting anything onto the model yet. Okay, we are just handling it. Okay, we are not transforming the data. We are just handling it in a separate way. Okay, because now you just assume it, you have a one part where you have the question and answer, right? You have a one syllabus where is only questions. Okay, that is your test data. Okay, so now here we are just keeping calling this function. It will set up its upper bound, lower bound, and then it will like here, once you calculate the upper bound, lower bound of your this data, then we will declare our library scalar, because you need to scale it now. Scale means like if there is an outlier, this means your values exist in your data set is in a different unit. How? I will tell you. Now look at this. So we have a two columns where is the outlier, right? So this is the senior citizen, okay? And this is your total charges, okay? Missing total charges, okay? So senior citizen, it should say like maybe senior citizen 1, 0. Either exist, either does not exist, right? Or we can check the value too here. Let me see here. So we will come back here. So this is a senior citizen, right? 0101, right? It should be this value. But why it is showing the like the here the outliers? If you have an idea, you can drop a comment in the comment box. Okay. Okay. So the reason is there might be some values exist, right? No, apart from 0 and 1 actually. Okay. There must be some other value, let's say 5, right? Let's say 10. So your like a data distribution is detecting it as an outlier. Okay. And when we like draw the graph here, okay, this is a bell curve shaped. So let's say there is a all senior citizen. Okay. The value is between 0 and 1. Okay. But there are some senior citizen exist whose value is going beyond it with the high units. So that's why this is outlier. Same with the your total charges. Maybe your total charges was between 20 to 120, but there are some total charges missing, right? Although it is saying the missing, right? It maybe it's a 400, 300. So these all are outliers because these points are very, very far away from your normal data points range. Okay. So that's why this is important to understand about the outliers. If you want, if you are thinking to delete it, think twice. Okay, because if you are losing 906 values from your records lines, you are going to lose the other data too, right? Your total charges, your churn, the predict definitely your dependent variable, your other variables like total billing, paper billing, all records are going to delete row wise, which we don't want. Otherwise, it will be your model will have a less data, right? After setting this, we are scaling it. Now you need to scale it. Okay. So we were here. I have defined and like told you what is outlier. When you are handling the outliers, now what it will do, I will give you the recap again. So this is your whisker plot. Okay. This is your median. Okay. This is your interquartile range. I, Q, R. And this is your Q1 and this is your Q3. Okay. So when you calculate the range, the Q upper bound and lower bound. So let's say I will draw this line. Okay. So it is showing you this balls, right? On the senior citizen and this one. So this is the one. When you like set the cap for this one, it will increase the boundary of your data like this. So whatever points are coming within this lower bound, let's say its range is it's at it minimum 10. So what values are coming within the 10 and it is going to like after that, right? If there are some data points like this above this range, it's set up 10. Okay. If it is going below than that, like let's say 0, not 0, sorry, 1.1 or 1, 2, right? So it is going to be not handle it. Then it will ignore this. But it will try to cover up more data points within this range. And let's say it is set up here 200. So it will cover up those one. So now this is called the capping, upper bound, lower bound. Okay. And then now it's a time to fit and scale it. Okay. I'm not fitting it on the model. We are just fitting on the instance of scaling actually. Scale means I don't want my units to be very like in the different way as I have showed you the example. If total charges are between the range 20 to 120, but there are some values like 300, 200, then if you don't scale it numerical data, your model may give the more weightage to the values which is above 120. Your model think like maybe it has a more importance than the other data points. So that's why your model sometimes become biased, which we don't want. So scaling of numerical data is must. Okay. So now here we are picking up X train senior citizen scale fit underscore transform. Now look at this method fit underscore transform. Mind it, this is not your model. This is the instance of your scaling method. Robust scaler we are using. Why we are using the robust scaler? Because this is you are helping to your handle the outliers actually. It is robust to outliers. That's why I'm using this scaling method. There are a multi-type of scaling methods available. You have a simple one is maybe you have heard this standard scaler. Okay, but I'm not using that here because I want to want something which can like a robust to the outliers. It will help at the back end. It will set some minimum maximum range and then scale the data. This is what we want actually. Okay. And then we will fit underscore transform means it will transform the data cap with the capping and fit onto this instance. Okay. But on the test, you should not fit. You are only transforming. Okay. This is the difference between train and test. If I give you the layman example, I have given you the question with answers for your preparation, right? But I have given you the sample questions only, or maybe the other content you can read from where the questions can come up. So this is that sample data. So I am not giving you the answer here. Fit means we are telling the answers too. Okay. So it will fit onto the scale too. We don't want for the test data. That's why we only transform the data. You need to transform the test data because you are going to put it into the machine, right? So this is very important. So you will again get a chance to understand it when I will implement the model. So now you need to do the same thing with the missing your total charges too. That's done. Okay. Now we will check after handling the outliers. When you run this, see there is a no outlier now. Okay, so how did you handle the outlier? Simply you have check it, you have set the, you find out the, pick up the Q1, Q3, and sorry, Q2, and then you find out the Q3, Q3 minus Q1, and then sorry, you need to find out the, sorry, not Q2, IQR, interquartile range, this one. Okay, so you will find it, and then this is a formula for lower bound and this is a formula for upper bound. That's it. And then you scale it using robust scaler. I have already mentioned why you should use a robust scaler. It's very simple. Maybe you are founding this code too much, but this is very simple. Don't worry, you don't need to cram the code actually. Don't try to cram the code. Just understand the logic, which method, why, which method, how I have used. That's it. You may take a help of Google to type the code. Okay. I also think myself, I always think about the logic actually. What is the best method? I also sometimes when I'm writing the code, I don't have a time. I use Google. Okay. So you can also use it. There is a no harm. Okay. And then here We are just checking the outlier. This is, we have plot the box plot. You can see there is a no outliers. Okay. Now we will do the logistic regression model implementation. You are done with the checking the missing value under what category. You have done with the handling the outliers. Now it's the time to handle the missing value. I did not handle it above because I want to teach you, it is going to be handled using pipeline and column transformer automatically. You don't need to do it separately actually. Okay. And then here I have written this function. I have written this function tenure. This is the custom function I have made. Why did I made it? Because did you remember it was saying use the conditional mean median method. Okay. So because your total charges is strongly correlated with the tenure. You have seen 85%. Okay. There are two ways. One way, you just take the mean of the total charges and you fill the missing value, that one. It's a simple scenario. Okay, you will take the mean of or average of your total charges, fill the missing value with that value. This is usually you do. This is called global mean. Okay, it sometimes it affects your model performance lot actually. This is not a good idea. Why? Because when you are like the one independent feature is connected with other independent feature too much, then you should do the group by method. You should put the conditional method. So because we will come to know here, group by tenure, total charges transform mean. So it will pick up the mean value after group by the your tenure, calculate the mean value based on that, and then fill it into your column. So this is conditional based actually. Biggest advantage, it will, your model will perform more better than the simple global mean. Okay, so this is most important part. And then we are just filling it here, and there are, I am making some changes here just to use it into the your column pipeline. I am using here function transformer. That's why. This is an inbuilt method. You don't need to do anything. We use it when you are using the conditional, your mean and median method. This is the most advanced method I'm telling you. Okay. So here you are passing this test. You are calling the function and validate is equals to false. This is your imputer is ready. With what strategy? Mean. Not only global mean, conditional mean. Okay, why we are group by tenure? Because your this total charges as you have seen above, right? I have showed you the relationship. That's why I told you it exists under MAR. It is strongly connected with tenure. That's why I'm using this method. Okay, so here we are fill now with the total charges mean by tenure. So you are filling it with using the simple fill now method. That's it. Okay, and then fill the remaining NaNs with the overall median. So here we are filling it with the median too, because when you do the median like the group by, it will create some NaN value too. Okay, because when we do the group by, it creates some NaN value. The reason like the group by is going to like join the your all values, right? Group by tenure means there are other columns like the total charges, one is missing, right? But where there is a no missing but it is grouping by tenure, it will create NaN by default. Okay, if you want to understand it at a deeper level, then you can print each and everything, you will understand. Okay, and you can also like go to the group by your method in the Python, so it will help you to understand. Okay, and then we have the, here is the pipeline. This is one of my favorite. I love pipeline because it's very easy to implement. Number one, it make your life very easy. Okay, so first we will make the numeric pipeline and column transformer is very good. Okay, in this it's nothing, you will create a one pipe. You have one pipe. Okay, so you are putting the one method inside it. First imputer strategy, you are going to handle the your missing data using this strategy, and then you are going to scale it in the one pipe. So you don't need to write your missing value handling or scaling separately. This is the biggest advantage. Okay, instead of like let's say I am giving you the green apple and red apple separately in a two poly bag. Instead of doing that, if I want to give you the both things, I will give you in the one poly bag, one big box. I will put all the green apple and red apple poly bags inside the big box and give you. This is more easy, right? Same the pipeline. Okay. I will make a visual video too on this one. Okay. And then here is the categorical pipeline. You need to create the categorical pipeline too with the imputed strategy if there is any missing value. And then we are converting it with the here your one hot encoder. Okay. Although we don't have any like the missing value in the categorical data, but I have mentioned it just for your knowledge. Okay. It is not going to harm actually anyway. And then we will create the column transformer. Now pipeline is a one big box. Now what is the column transformer? Column transformer we use so you can club the both pipes because you have a two pipeline, right? You have a one for numerical data, one for categorical data, right? Both contains their own strategies. Okay. So to do that, you want to put them into now more bigger box, both one. Okay, so you have put the both into the one more bigger that is called column transformer, and then we will create the model pipeline now. So model pipeline is nothing, you can name it with the preprocessor. This is column transformer which you have created. Column transformer contains your all information, how you are going to handle the missing value of the numerical data, then you are going to scaling it, if you have a categorical data, if there is a missing value, you are going to handle it with most frequent, and then you are giving the data to. So you can see the biggest advantage. I don't need to do everything fit to transform separately, right? I can do it in a one go. It's so easy. And then we are declaring here your model logistic regression with the random state too. And we can do one thing here if you want. We can here your try to type this one. Okay, so we can type here look at this. So it will give you the more clear picture. Look at this. So this is all step. This is I was telling you first. It will read your num columns. You are selected, right? You separate the categorical and numerical data from X train, and then you are applying the one hot encoder on this one. Okay, because this is categorical. If you want to look for the numerical pipeline, you can also look for this picture too. So here this is this one, and then we can draw this one too. So it will make more sense to you, but definitely I will try to make a video on this one. So this is showing you the complete flow. Okay, and if you want to look for the column transformer, you can also look for that one too. Here we go. Okay, so you can see now both your pipeline is inside the column transformer. That's it. Here we are just creating the model pipeline because I want to apply the model now. Now come to jump to this point. Now model pipeline dot fit X train Y train. Now you have splitted the data above. You are going to fit the X train Y train onto the model pipeline. That's it. Okay, it's so easy. Tomorrow, if you want to make any changes in your strategy, you don't need to write the loose code again and again. You just need to change the strategy name here. That's it. This is the biggest advantage of your this pipelines. Okay, and then you are going to here fit on the X train this one. We are fitting only the train data on the model. We will not fit the test data because there will be the data leakage. Okay, so here we will this one under the column you are may thinking where is the transform is automatically happen with this one. You don't need to write any extra step. That's why this is the biggest advantage of transformer. Okay. And then we are fitting only the train data because we don't want data leakage. There is a no test. So now you can check the score using the simple model pipeline dot score extra. Next test this one. So training score is 80%, test accuracy is 81%. It seems to be good. I will not say it's not too bad, right? And then now look at this. Here I will like say now this is the accuracy one. So I'm thinking I will like explain the next part tomorrow in detail because otherwise video will go too long. Okay. So we will stop this one here. Tomorrow in the part 3, I will start from here. Okay, with the evaluation. And I will also let you know the second, I will also use the one more model and then we will do the comparison with all these steps. Okay, so what I am going to do now here, we will here end off this session. Okay, and we will like complete it tomorrow in the part 3. Okay, so now this is what you have learned till so far. Okay, so you have learned about the first checking the missing value, and number 2 under what category your missing value lie, MCAR, MNAR, MAR. Sorry, so you can decide which method will be more beneficial for to handle the missing value. This is the most important part. Okay, if you have any question, drop a comment in the comment box. Okay, I will, even you are stuck in somewhere, you need a solution, I am happy to make a video on that. You only need to send me the data set or your file. Okay, because I used to make a videos on the real time problems of the students too, so other students can learn from it. Okay, and the third thing, you have learned how to use the pipeline and column transformer, which is very important. Okay. My recommendation to all of you is use pipeline and column transformer instead of just writing the loose code because it is the very biggest advantage for this one. I will definitely make a visual video too on this one in the upcoming days, but tomorrow we will again continue the same. You have also learned the how to apply the logistic regression. We have also seen the accuracy of on the training and test both. Tomorrow I will continue with the evaluation metric of the logistic regression. Plus, I will also show you the random forest classifier tomorrow. Their like the evaluation metric too and their hyperparameter too. Okay, so you can learn the complete classification, your machine learning life cycle. Okay, so this is my goal. And if like I have a lot of things like to share with you. So this was all about today's session. See you tomorrow in part 3. Keep learning, keep patience with science data science. If you are new to my channel, don't forget to subscribe my channel and don't forget to hit the bell icon button. Okay, too. So thank you so much. See you in the next video and stay connected and learn from each and every part of the video. Okay, thank you.